Here's the next lesson of the matrix, and in today's lesson we'll continue where we have left in the last lesson. Types of the matrices. In the previous lesson we had talked about the major matrices, let's say square matrix, symmetric matrix, skew symmetric matrix, and many more. And in today's lesson we will talk about, orthogonal matrix, conjugate of a matrix, matrix A theta, unitary matrix, Hermitian matrix, and skew Hermitian matrix. So let's just start with the first definition, that is the orthogonal matrix. So if a matrix A, let's say if A is a square matrix, then if we'll product this with its transpose and we obtain identity matrix, then the matrix A is said to be orthogonal matrix. So here we are using two different definitions. One is the transpose of a matrix and the other is identity matrix. Both these definitions I have covered in my previous lesson. So if you have not seen that video, please go and watch that video and know what is a transpose matrix and what is the identity matrix. So orthogonal matrix is a matrix when it is producted with its transpose, it gives the identity matrix. Let's see this with one example. Let's say if we have a matrix A which is having the values cos theta, sin theta, minus sin theta, and cos theta. So we need to check whether this given matrix A is orthogonal matrix or not. For that we need to obtain its transpose. So let's get this transpose. So the transpose of the given matrix A can be obtained by interchanging its rows and columns. So now I am going to convert this row into column. So this is cos theta sin theta will be written as cos theta sin theta, and this row minus sin theta and cos theta. So we have interchanged the rows and columns to each other, and now we have obtained this transpose of the matrix. Now let's product these two matrices A and transpose of A and see whether the resultant is an identity matrix or not. So let's product A dot A dash. So this will be equal to, let's say, cos theta sin theta minus of sin theta cos theta. This is A, and on the right hand side we have transpose of A, that is cos theta minus sin theta sin theta, and this is cos theta. Let's have a product. So we product this column with this first row, and then we have cos theta into cos theta, this is cos square theta, plus sin theta into sin theta, this is sin square theta. So this is the first element of the product. Next is we'll multiply this row with the second column. So we have cos theta into sin theta, this is minus of sin theta cos theta, and then we have sin theta and cos theta, so this is plus sin theta cos theta. So this is the second element of the first row. Now let's multiply this second row with the first column to obtain this element. So this is minus sin theta into cos theta, this is minus sin theta into cos theta, plus cos theta into sin theta, so plus cos theta into sin theta. So this is the first element. Just to obtain the next element, we'll multiply this row with this column. So now we have minus sin theta into minus sin theta, that is sin square theta, plus cos theta into cos theta, this is cos square theta. So this is the product. Now let's solve it. As we can see here, minus sin theta cos theta sin theta will cross out. This is minus sin theta cos theta sin theta cos theta, this will cross out, and we have 0 here and 0 here, and we have the property that cos square theta plus sin square theta is always 1. This is the trigonometrical property. So we have 1 here, here we have 0, here we have 0, and this is also sin square theta plus cos square theta comes to be 1. So this is the resultant matrix, and we see that this is the identity matrix. Yes, a matrix with diagonal elements all are 1 and all other elements are 0 is known as the identity matrix. So this given matrix A is the orthogonal matrix. So here we have the first definition, that is orthogonal matrix. So the next definition is of the conjugate of a matrix. So before we talk about conjugate of a matrix, let me tell you what we mean by the conjugate element. If we have a complex element, let's say 2 plus 3i, then its conjugate will be 2 minus 3i. Yes, we change the sign of the imaginary term. We revert the sign. So if this is plus, then this will be minus. If we have, let's say, minus 2 and minus 3i, then its conjugate will be minus 2 plus 3i. Remember, we only change the imaginary term's sign. So this is the conjugate of the given element. So what is a conjugate of a matrix? So conjugate of a matrix can be obtained by replacing the elements of the matrix by its conjugates. Let's see with one example. Let's say if we have a matrix 2 plus 3i, 5, 3 minus 4i, let's say 6, 2 plus 3i minus 2 minus 3i. This is a matrix. Then what will be its conjugate? Yes, its conjugate matrix will be returned by, will be obtained by replacing its elements by their conjugate elements. So this is 2 plus 3i, its conjugate will be 2 minus 3i. This is 5. As we do not have any imaginary term in this, it will be written same. This is 5. This is 3 minus 4i, this will be 3 plus 4i. 6 will be written same, 6. 2 plus 3i will be converted to 2 minus 3i. And lastly, minus 2 minus 3i, so this will be minus 2 plus 3i. So we have written the conjugate elements here, and this matrix will be known as the conjugate of the given matrix. So this is the conjugate matrix. Now let's talk about matrix A theta. So matrix A theta, what is matrix A theta? This is the transpose of the conjugate of a matrix. Yes, so we need to memorize this conjugate definition, and once we get the conjugate and then if we transpose the matrix, that will be the matrix A theta. So let's see with an example. If let's say we have A 3 plus 4i, 5, 2 minus 3i, let's say 2 plus 3i minus 2 minus 3i, if this is a matrix A. So first of all, we need to find out its conjugate. So let's write the conjugate of A. So this will be, we need to write the conjugate elements. This is 3 minus 4i, this will be 5, this will be 2 plus 3i, the 2 will remain same, 2 minus 3i, and this is minus 2 plus 3i. So this is the conjugate. Now we need to perform transpose of this conjugate to obtain A theta. So what is A theta? This will be the transpose of the conjugate. So let me write the transpose, and we can obtain the transpose by interchanging rows and columns. So I'm converting this first row into first column. So this will be 3 minus 4i, 5 and 2 plus 3i. And then this row will be converted to next column. So this is 2 minus 3i, and this is minus 2 plus 3i. So this matrix is called as the A theta matrix for the given matrix A. So there are two steps. First, convert this into the conjugate and then transpose the conjugate to obtain A theta. Now let's talk about the next definition, that is unitary matrix. So what is a unitary matrix? If a matrix A is multiplied by its A theta and the resultant is an identity matrix, then the matrix will be termed as a unitary matrix. So let's understand this with the example. Let's say we have a matrix A here, which is 1 plus I upon 2 minus 1 plus I upon 2, 1 plus I upon 2 and 1 minus I upon 2. So first of all, we need to get this A theta. Remember, we had seen A theta. So just to obtain A theta, first we will get the conjugate of the above matrix. The conjugate of this will be 1 minus I upon 2, minus 1 minus I upon 2, 1 minus I upon 2, and 1 plus I upon 2. So this will be the conjugate, and from the conjugate we want to transpose this to obtain A theta. So now this A theta will be equal to the transpose of this matrix. So this will be 1 minus I upon 2, minus 1 minus I upon 2, and this row will be converted to column, 1 minus I upon 2, and this is 1 plus I upon 2. So this is A theta. Now we need to product these two, A and A theta, together to obtain the new product matrix. So let me write it here. This A theta I'm writing above 1 minus I upon 2, so that it will be easy for me to get the product, minus 1 minus I upon 2, and this is 1 plus I upon 2. Right, so let me perform the product of these two matrices using the product rule of the matrix. So now this will be 1 plus I upon 2 multiplied by 1 minus I upon 2, 1 plus I and 1 minus I. This will be A plus B and A minus B. So 1 minus I square upon 4. So this is the first one. Next is minus 1 plus I upon 2. So this is again A minus B. So this is minus 1 square and minus I square whole upon 4. So we have this is the first element. So we have this as a first element. For the second element, we'll multiply this row with this column. So this will be 1 plus I upon 2, 1 minus I upon 2. This is 1 minus I square upon 4, then plus. Minus 1 plus I upon 2, minus 1. This is minus 1 plus I, and 1 plus I. This is whole upon 4. So this is the first row. Next row, we'll multiply this row with first column first. So we have 1 minus I square upon 4, and then plus we have 1 minus I multiplied by minus 1 minus I whole upon 4, and then we'll multiply this row with the top column. So 1 plus I and 1 minus I. This is 1 minus I square upon 4, and there's 1 minus I into 1 plus I. It's again 1 minus I square upon 4. So this is what we have, and then on solving this we'll be able to see that this is 1, this is 0, this is again 0, and this is again 1. So we have 1, 0, 0, and 1. So we have the identity matrix. So hence we can say that the given matrix A is the unitary matrix, as the product of A with A theta is an identity matrix. The next definition is Hermitian matrix. So let's see what is the Hermitian matrix. Any square matrix, let's say any square matrix, will be termed as Hermitian matrix if for its all ijth element is equal to the conjugate of jith element. Right, it's equal to the conjugate of jith element. Let's see this with the help of the example. So first of all, we need to have a square matrix. Let's say if we have 3, 2 plus 3i, 4 minus I, 2 minus 3i, 4, let's say minus of 5i, 4 plus I, let's say 5, if this is 5i and this is 6. So if this is a matrix, so we need to check the two things, that this has to be a square matrix. Yes, this is a square matrix with 3 rows and with 3 columns, and the order is 3 by 3. Then every ijth element needs to be equal to the conjugate jith element. So let's say if we have the element a1, 2. What is a1, 2? First row, second column. First row, second column. Let's say 2 plus 3i. Now this should be equal to the conjugate right of a of 2, 1. conjugate of A of 2, 1. Aij, Aj, that's it. So what will be the conjugate? So 2, 1 is 2 minus 3i, and if you'll see that 2 minus 3i is A21. Second row, first column. So we need to compare this and this element, and both these elements must be conjugate of each other. And we can see if this is 2 plus 3i, this is 2 minus 3i. Yes, this is conjugate of this. That means both are conjugate of each other. So this condition is true for A12. Let's talk about this. This is A13. Then what will be the element we are looking for? A31. This is A31. So we can see 4 minus I is a conjugate of 4 plus I. The next, let's say if we want to see this, what is this element? This is A23, second row, third column. If this is A23, then we'll see A32. This is A32. So this is minus 5i, this is plus 5i. So we can see that all the elements in this matrix, according to this Aijth element, for all, this is for all true, that all such elements are conjugate elements of the Aj elements. So this matrix will be termed as Hermitian matrix, right? This is the Hermitian matrix. Now let's talk about the skew Hermitian matrix. It's a little bit similar to the Hermitian matrix with a very small change. The condition 1 remains same. Any square matrix, it has to be a square matrix. And second condition, ijth element should be equal to the negative conjugate complex. It should be equal to the negative conjugate number of the jith element. So this is an addition. So let me change this. If I mark some signs, let's say if I do this negative, if I do this negative, and if I do this negative. Now let's check. So that should be, so what should be the condition? The condition should be that if I see an element A12, then it should be negative of conjugate of A21. Right, so let's see, let's check. What is A12? This is minus of 2 plus 3i. Now what is A21? Look at this. This is the conjugate. 2 plus 3i's conjugate is 2 minus 3i, and this is negative. If this is negative, this is positive. So opposite in sign. So here the condition applies. Let's say if this is 4 minus I, then what is the conjugate of this element? This is 4 plus I, and these both are negative in sign. This is negative and this is positive. Now let's see. This is minus of 5i. This is A23. Then what we should look? A32. So minus of 5i. The conjugate of minus of 5i should be 5i, but these both should be negative. So this is minus 5i and this is minus of 5i. So here the condition is that ijth element should be equal to the negative conjugate of jith element. So this is the skew Hermitian matrix. So I have tried to cover all the definitions here into this types of matrices second lesson. I hope you have understood these definitions. Feel free to ask your queries, if any, into the comment box. Thank you so much.